Hello, good evening, good afternoon, good morning. This is Viral Trivedi from Network Intelligence, a global cybersecurity company out of Mumbai headquarters, and also joined by our marketing head Anurag. And we are looking forward to this particular webinar, where we'll be talking about industrial IoT and cybersecurity risks and solutions, as well as what are some of the different options and solutions that focus on the architecture of industrial IoT solutions and cybersecurity of ICS environments. Having said that, let me start with the presentation. And given that in a few moments we'll be going through some slides, and we will keep the last 15 minutes for live Q&A. In the meantime, you can also ask questions on the YouTube, which is on the right side of your video screen. So we are going to start right now. Okay, I hope you can see my screen, where we are going to talk about critical infrastructure and what are some of the different challenges organizations face during implementation of their critical infrastructure security. Why critical infrastructure security has become such a topic among CISOs, as well as among a lot of plant operators, as well as IT community. As we progress into the modernization of our critical infrastructure as well as industrial control systems, many folks have started seeing integration of industrial control systems with IT environments. And the reason we are going to look into the integration of IT with industrial control systems is because more and more organizations are trying to use industrial IoT platforms, and they are trying to integrate data analytics, collecting data from the sensors, and making sure that they get the operations efficiency of their plant equipment or the industrial control systems, as well as getting their asset performance management data on their industrial control system equipment. So we're going to discuss some different attacks that have taken place in the ICS space. As we know that the Ukraine's power grid was impacted by Russian hackers, which took out electricity for over 700,000 users and homes. We also had China's attack that could have had a US power grid with cyber attack, as it was in the news that NSA chief that China tried to shut down the US power grid with a cyber attack. We also had the major banks in United States that were attacked by the Iranians trying to make a plot line of a movie that eventually came out, but the dams were attacked and the cyber attacks on different banks. Federal government lacked the methods to grade critical infrastructure cybersecurity, and eventually what happened was that all these different methods were being generated, were being shown, but the truth is that our critical infrastructure is being impacted either through cyber attack due to integration with IT systems, or purely at the state level. As we know that cybersecurity attacks or cyber attacks or threats against countries' critical infrastructure has become a major issue due to all these different attacks on the power grids, on the dams, and all the news articles that are popping up regarding these threats. Now, is this a new problem? Honestly, it's not a new problem. These problems have already been there. It's just that it is coming into limelight right now as more and more organizations are facing these kind of threats and attacks. Either it's in the oil and gas industry, either it's in the shipping industry, or it's in the power and utility industry. But are these threats becoming more and more live? I was in a conversation with a CISO recently where they were talking about such attacks, and they asked the board members that, is this a risk or is this fear? When there is a likelihood of something happening, it is not just fear, but it's definitely a risk. And risk can be mitigated if we know about the risk prior hand. So as we know that our critical infrastructure environments are getting more and more integrated with the IT environments, we are seeing a lot of activity of remote connectivity or connectivity to the internet or connectivity towards remote users trying to operate or monitor and diagnose their plants or factory floors. So as these utilities or these power plants or these factory floors or these oil and gas refineries get more and more connected, the threats are going to increase. So before we go further, I wanted to address that what is industrial control systems and how the architecture of that industrial control system is defined or should be defined for a good cyber hygiene. So in this particular famous Purdue model where IT and OT is being discussed, as you see at the bottom of the slide here, we are talking about sensors, drives, actuators, robots, or practically the machine. This is where all the data is being either collected or measured by the equipment sensors. Level 1 is where all the different controls that go into play. So for example, the PLC is sending a command to the sensors or to the equipment to perform a certain function. Level 2 is where the engineering workstation, SCADA environment, or SCADA systems are sitting. Level 3 is where the HMI, human machine interface, the laptop or the desktop or a workstation that is allowing a site operator to send those commands through the distribution control systems into the PLC, which eventually allows the equipment to perform that certain function. Now, this particular environment is called the industrial zone, where all the industrial equipment is sitting. Now, as I mentioned in the beginning of the slides before we started, that as more and more ICS environments are integrating with IT environments, either into the cloud or through enterprise networks, there has to be a segregation or a point of entry. So that's why we define an industrial DMZ or industrial dematerialized zone. This is where all the different security services, application services, patch management services, antivirus is sitting. There is a firewall that is separating the DMZ, industrial DMZ, from the true industrial zone, which is at the bottom, which is level 0 to level 3. Traditionally, there is a word that the industrial DMZ is called the 3.5 zone. And then level 4 and level 5 is your legacy IT environment, which is either your corporate intranet or your business network, where folks are either using email, internet, and all the other activities that happen in the IT environment. So this is a generic Purdue model architecture where OT and IT are shown to be integrating together and is separated by an industrial DMZ. So what is the major difference between OT and IT? Well, IT communications rely on TCP/IP stack, as you see on the left side of the screen, where there are different type of protocols that are being used, and we are seeing that it has the internet protocol, it has a lot of SNMP, FTP, email, network management, hosting, DNS, stuff like that. So these are our traditional TCP/IP connected networks. While in the ICS or the OT environment, the protocols that are used to control these devices, to communicate from PLC to the sensor, HMI to the PLC, or PLC to PLC from the engineering workstation in the previous model that we just saw, these protocols tend to be mostly found in the level 3 or below, as you saw in the previous Purdue model diagram. Some of the examples of these protocols are Profibus, Modbus, MQTT, DNP3, Ethernet IP, and these protocols do not operate the way the TCP/IP or the IT protocols are operated. So one of the major differences that the communication in the IT and the communication OT has completely different sets of rules and different sets of protocols. So now if you look at a network diagram of the previous Purdue model, this is what the network diagram looks like, where at the bottom of the screen, you will see sensors, PLCs. In the middle of the screen, you will see SCADA environments. You will see DCS, distribution control systems. You will also see a switch that basically has a properly segmented and VLAN environment, as well as you will see engineering workstations on the top left, where all these users are connecting and sending commands. And then between the industrial network, which is the middle network, is the industrial DMZ, and then all the IT related activities happen in the top, which is the WAN environment of the enterprise. So as you see, all the protocols that are being defined here in the ICS environment are Modbus, Profinet, Ethernet, as I mentioned. They sit in the bottom level of this architecture, versus the IT Okay, we are back online. Apologize for the technical difficulties. Okay, so as we were on our previous slide, we were discussing the differences between IT protocols and OT protocols and how they are separated from a network diagram point of view or architecture point of view. So why is it, so now that we have learned about different different protocols and how IT is different from OT or ICS, I would like to discuss why the industrial control systems cannot be protected using the IT methods. So securing the ICS environments or the OT environments IT way, is that something that most of our organizations are aware of? They are trained, they have the skilled employees in the IT technologies, tools, but everybody has this question like, why can't I just do the same thing in the ICS environment? So here we are going to discuss that many of these IT professionals try to secure the ICS network by extending the process that is used to secure the OT environment. And this might be applicable up to the 3.5, the DMZ environment, or some of the engineering workstations that are part of the level 3 as discussed in the Purdue model. But most of the ICS systems are so sensitive, and these devices that are built with very limited memories on it, they have these device related restrictions. So the processing power on these equipment, the memory on this equipment is so low that if you run a, let's say, a NESA scan or some kind of a IT tool scan on these devices, they might just break down or hang, just like my computer hung before. So something like that can happen in a processing. So if my computer was, do we have a question online? KKY, what is that? Anyway, I'll address that as we proceed. So as we are talking about that these different devices have restrictions due to limited memory, limited CPU processing, the IT tools cannot be used because, as you noticed just recently, my computer just got blocked, or not blocked, but got hung up, and I just rebooted. Nothing major happened, no major catastrophic event took place. But imagine if you're in a power plant and you try to run the IT tools to scan the ICS environment or ICS equipment, and suddenly the PLC hangs. It's no longer sending functions and commands to the equipment that is either generating power for that power plant, or it could be manufacturing a particular set of products that could stop production, which means a lot of financial loss. If power is lost in a particular power plant, which means homes are without power for an extended period of time until everything comes back to normal. So one of the reasons why you cannot use IT is that these devices are extremely low in memory and CPU processing power, and if we try to use them, they can be shut down or disturbed from processing any further functions. The second reason why we cannot use IT tools or ways of IT in securing the ICS environment is the network related restrictions. These environments require very high-end real-time communications. If you're trying to send a command to a turbine that is generating power to stop generating power, it requires real-time functions and real-time commands to be processed. Now, if we try to put IDS, IPS, intrusion detection systems into these environments, it adds extra latency and extra delays in processing the commands that are mission critical. The third reason we cannot use IT tools and systems to secure the ICS environment is because of safety reasons. In case of emergency, the ease of access is of utmost requirement and importance. So example, if I'm on a ship which needs to change course, the example of Titanic, if it was using a modernized technology where they had to process some commands to change directions, it needs to have an immediate access to the workstation that can send the command to the engine room and the propulsion systems to change the direction. Now imagine you have a very secure password and you have your screensaver on, and these commands need to be sent in the next few seconds. Now that complicated password can delay the processing of that command. So that's one of the examples of how safety-related restrictions prevent us from using the IT methodologies to securing the ICS environment. And the last one is the runtime and uptime requirements. The runtime requirements in ICS are extremely high because they are defining production, defining efficiency, defining in a critical infrastructure such as a power plant or refineries. They are generating some high mission critical environment. They're operating in a high mission critical environment. So if we try to say, okay, I want to do a patch update, so maybe do it in IT, or I want to do routine weekly maintenance of making sure that our firewalls are up to date. So I need to reboot after applying some Windows updates. Those kind of activities cannot be tolerated because the downtime can be extremely high or long. If those downtimes are long enough, the production environment in a factory floor can be impacted, or in a power plant can be down and not be generating power, or as we mentioned, the example of a ship, they only have limited time on the ports before they have to take the next set of passengers or shipping containers as they are time bound. So those were some of the reasons why you cannot use IT methods or IT ways of protecting the ICS environment. So what are some of the different attack vectors that are available out there or are out there in the ICS environment? As everybody, some of you or many of you must have heard the concept of air-gapped environments. ICS is air-gapped. They are siloed, they're separate, they're never connected into the outside world. So why should we be worried about cyber attacks while they're not connected to the outside world? As one of the famous cyber attacks on the critical infrastructure was the Stuxnet incident, where somebody had had plugged in a USB onto the SCADA environment workstation with a malware. And that particular malware started doing its thing and started working and looking for connectivity to the PLC, looking for connectivity to the rest of the DCS, distribution control systems, the control network, and eventually perform the damage. So here, this environment was not connected to the outside world, and somebody plugged in a infected USB into one of the workstations, and it caused severe damage. So one of the attack vectors is infected USB keys. Second is many of these ICS equipment have OEM vendors such as Siemens, Honeywell, GE, and these PLCs have to have some sort of maintenance done by these vendors. So they have some sort of remote access into the ICS environment. Yes, lately in the recent times, these environments have been protected via firewalls. But again, it's a piece of technology. If a firewall can be hacked, these remote access can be compromised, and these PLCs can be accessed, and changes to the functions and commands can be made. Uh, if they are connected to the enterprise network through the DMZ, the firewalls can be misconfigured. The firewalls can have bad rules and policies defined, or incorrectly defined, or somebody can do a DDoS attack and break down the firewall, and the connectivity can be disrupted. But when by the time the network comes back up, there is a small window where somebody can attack before the firewall rules take its do its job. Um, Many organizations can also have unsecure wireless environments in their industrial control system. Somebody can also bring an infected mobile cell phone or a mobile device and say, "Hey, let me use the the workstation in the ICS environment and charge my phone." Now, unknown to the user, they might not know that their mobile phone might be infected with some kind of a malware or virus, which can impact the industrial control system as soon as they uh, plugged in their mobile phone into the ICS workstation to charge their device. The last is people can bring their own devices such as laptops or iPads, and they can connect without being aware of any kind of viruses or malware that are part of that environments of their laptops or their devices. And they might just say, "Hey, let me just connect to the Wi-Fi. I want to print my son's or daughter's homework. So let me try to do that because I brought that from home." So these are some of the attack vectors that we see in the industrial control systems or OT environments. So as we see that there are a list of potential impacts, as we know that NIST, the National Institute of Standards and Technology, had released the version 800-82 Rev 2, where what is the impact of a cyber attack on the industrial control systems or critical infrastructure? So the first one is pretty serious, is the impact on national security, where it can be which can be seen as a facilitated act of terrorism. Somebody can attack the United States or the country's power grid, and we could have power outage for half of the country. There could be reduction or loss of production. We gave an example of a factory floor where you are probably in a pharmaceutical industry, or if you are in a fast-moving consumer goods. If your ICS environment or your production environment is attacked due to some kind of illegal cyber activity, you can lose the production value as well as that can lose the revenues in the coming months. Uh, I think the most important one is that these systems are so physical and cyber physical. There could be injury or death of employees if a certain centrifuge in a power plant or a certain equipment is misconfigured to perform some activities that that the machine is not supposed to doing. For example, a machine is normal behavior is running at 1,000 rounds per minute, and if there is a misconfiguration and it starts running at 10,000 rounds per minute, uh, it can cause a severe damage. The machine can explode, and that can cause injury or to the employees that are working in that environment. The example of injury to the community. So if let's say somebody accesses the dam, a water dam, which is protecting the water from overflowing, and I'm sure there is a PLC that is controlling the opening and closing of the dam. This particular community can be impacted if somebody misconfigures the door opening schedule and suddenly the water starts coming flooded. So the community can be impacted. There could be deaths or injury to the local community. Absolutely, the equipment can be damaged, and these equipment are extremely expensive. There could be release or diversion of hazardous materials if you're in a highly controlled environment for pharmaceutical environment where chemicals are being processed or used for certain production. So if somebody misconfigures a PLC or an asset that starts releasing something that is not supposed to, that can also lead to an environmental damage. Uh, and then when you are in a regulatory industry such as power and utility, if you don't follow certain security controls defined by that regulation in that industry, then there are definitely hefty fines. NERC-CIP, for example, in United States, has a hefty fine of $1 million a day if the compliance is failed for the security controls that are defined in the NERC-CIP environment. Somebody could be trying to steal financial information or illegal money transactions by accessing the ICS environment. Loss of your intellectual property and proprietary information. Somebody can steal the formulas that are being used in a factory floor to create some unique medicine to cure cancer, for example. And definitely, last but not the least, is that when all of these things happen, your brand image and customer confidence gets impacted. So these are some of the few, but not limited impacts of cyber attack on a critical infrastructure or industrial control systems. So what can be done? What needs to be done? Well, IEC 62443 is one of the security standards for industrial automation and control systems. This particular framework defines all the different security controls that are part of the industrial automation and control systems. This is just one of the framework. There is the industrial control system security framework, which is provided in NIST 800-82. Department of Energy also has different steps defined to improve the cybersecurity of the SCADA environment, as well as the North American Electric Regulatory Commission has their NERC-CIP compliance. There's a checklist provided by NCSC, and that checklist also helps you define different security measures for SCADA and ICS systems. The United States government also has a cyber risk management process guideline. The Department of Energy has a C2M2 cybersecurity capability maturity model, which helps organizations in the oil and gas or electricity subsector to define the risks based on their equipment, their readiness for security, and their operations. And there is definitely a procurement language for energy and delivery systems. Now, these are just some of the frameworks. There are many other frameworks out there that help you define a secure environment and define different security controls for your industrial control environments, OT environments. And as IIoT is coming to life, more and more of these frameworks are getting customized by organizations based on their industry vertical. So if you need help in defining which particular framework is required or good for your environment, absolutely, network intelligence team of ICS experts can help you with that. But we'll talk more about that later. But why does OT security need to be treated differently to IT security? Now, as we discussed certain technical reasons in the past, in the slides before 15 minutes ago, here I would like to focus on certain requirements that are not just technical, but more on the softer side. For example, the vendors that you deal with in your ICS environment should be having a proper secure remote access, which we discussed in the attack vectors. Any kind of modifications without the vendor approvals also voids guarantees. So you can just go and start opening up your ICS systems and say, oh, okay, let me go try to break into this environment, do a red team assessment, a penetration test. Because if you start doing that, you're your warranties and guarantees with the vendor might get impacted. Safety and different safety regulations can be complex and overlapping, and it will conflict with your cybersecurity models and frameworks that you might have defined in your IT. One of the things that I've noticed that all these ICS environments have so many different vendors. As I gave names of few vendors in past a little while ago, this can complicate things further because every vendor wants to access their environment through their secure measures. So how many different remote connections are you going to provide in your ICS environment? Uh, the other thing is that the equipment life cycles of these environments are much longer. These equipments have been sitting in these environments for almost a decade or two. So the systems and the likelihood of the systems being obsolete is very high. I have been in many factory floors and power plants where customers are still using Windows XP. So these systems, they're saying, well, it's working. Why should we bother changing it? Uh, there are definitely no major UAT environments available. Downtime is not possible, as we discussed, for patch management. And definitely the protocols that we showed before are not really built with security in mind. So these protocols have no encryption, no two-factor authentication type of services that can be supported. You cannot just do vulnerability assessments, which are very intrusive and actively done on these equipment. So OT security definitely needs to be treated differently than the way we handle IT security. So these are some of the trends and threats due to the Internet of Things. A lot of connected cities, connected infrastructure is coming together. Cars are becoming smarter. Virtualization and cloud solutions are becoming part of the ICS environments. And this is definitely increasing the attack vectors in the ICS environment. So how do we approach security in the ICS or the OT environments? So as we see, that first step is to have our leadership or the organization leadership and the stakeholders to be aware that how the security posture of both environments, IT and OT, as they converge together, needs to be taken seriously. Secondly, the plant environment, your security teams, the leadership should also be defining a separate OT cybersecurity leadership or a CISO for the critical infrastructure or the ICS environment. And then that person will be focusing on staying ahead of the different threat landscapes that ICS security is exposed to. Then definitely having and establishing a end-to-end cybersecurity framework, either by referring to the ones that are available for each and every industry, or something like NIST or ISO 27001 or IEC 62443, the ones that we mentioned before. Absolutely defining and harmonizing security processes and technologies across both organizations and different geolocations. Next one is enhancing the team's capabilities, the team's training, awareness around security methods for the ICS environments. Prioritizing future investments to protect the security infrastructure of the ICS environment, and making sure that these investments are made on a timely fashion. And definitely having a proper manageable dashboards for your security events, logs, analysis, and it should be visible at different levels of management. So how can NII help in providing you that end-to-end framework and a program that we work? At NII, we start with an initial assessment and discovery where we are classifying your assets, understanding what is out there in the ICS environment, having to see how many PLCs, what are the different vendors, what kind of operating systems are being used on the workstations, how is the connectivity defined, what kind of connectivity is there between the IT and OT environment, what kind of remote access is available for vendors. So what we do is we basically assess your infrastructure and define your critical assets, and see if there is a framework that can fit your existing environment. If there is not, then once we conduct the non-intrusive exercise of understanding your infrastructure, we try to come up with a plan and define a cybersecurity framework that fits your industry and your organization's needs. Uh, as we go proceed from the next few weeks after the original assessment is done, where we define certain vulnerabilities, uh, define a risk posture, we come up with a security roadmap development to see what kind of policies, procedures that need to be built, what kind of awareness training that needs to be done, what kind of a baseline that needs to be created based on your industry vertical. Last is establishing monitoring infrastructure and processes. If you are a very matured organization from a security readiness, then there are we will help you define a established monitoring and security operations center processes, so that you can have a proper command center, do some advanced security war games, where you are also doing advanced adversary simulations of your ICS environments, and then on ongoing 24/7 basis, you're monitoring your environments. The deliverables that come out of this engagement from NI's point of view is that we will definitely define your risk posture. We will help you analyze what's available out there in your environment, classify your assets, and as we all know, you can't protect what you can't see. So we will give you a full-fledged view of your ICS environment from assets point of view. And then from there on, we will come up with different roadmaps and security framework development and other infrastructure processes and policies and procedures for you. So what does a maturity assessment look like? This is just an example of how a cybersecurity framework gets applied. I have specifically taken an example of NIST cybersecurity framework here, and we are going to show you that this is what a NIST cybersecurity, which focuses on maturity ratings. We give you a risk score of how mature your organization or a business unit is. We define a risk and an impact statement. We do a comparative analysis, and we define a strategic program recommendation, as I showed in the previous slide. So this is just an example of the NIST cybersecurity framework. So final takeaways. So what you should be doing in order to get your ICS security strategy defined. First, you need to get your management buy-in, help them be aware of all the different threats that are out there. Having all the team aligned, which is your IT and OT teams, plant teams, operators, be aware, so that everybody knows that due to innovation, we are moving towards digital transformation and industrial IoT, the security threats will be bigger. So having them understand why they need to focus on cybersecurity is very important. Definitely having hardened privileged workstations in your ICS environment. Always assume that breach is going to happen, so incident response and security monitoring should be present. What are the different security technologies out there that can help you prepare for a ICS cybersecurity architecture and framework? Utilization of tools such as data diodes or industrial firewalls, blockchain-based identity access management solutions, segmentation, network design, all that stuff needs to be taken into consideration. You need to constantly monitor your cybersecurity matrix and have a program that works for your industry, and eventually integrate this into your overall framework for your organization. So if you're in a regulated industry, you need to make sure that you are compliant to certain mandates that that particular industry is requiring. So those are some of the final takeaways, what you need to do in order to protect your ICS environments. This is a very high level overview. We definitely go into a deep dive environment. My LinkedIn and my email is on this last site. You can always contact me or anybody from Network Intelligence. I'm available for questions out here for the next 10 to 15 minutes. So please feel free to ask your questions on YouTube chat. Thank you for your time and thank you for attending this webinar.